Welcome back to Make Games with No Money or Experience. In the last episode, we went over the Godot interface, saving, and how to add nodes. We also introduced the button and Node2D nodes. Today, we're going to go over the inspector, right over here, and write a little code. Just a warning, this episode is probably going to be a little bit dry, but that's because the coding principles we set up now will affect all the code you're going to write from now until you die. It really is important that you understand the basic concepts we establish in this episode. I recommend you include in your game all the notes that I write in mine. That way you can reference this game when you're learning. I promise once we have all this stuff down, the upcoming episodes will start to move quite a bit quicker. So, let's start by selecting our button. To the right in the inspector, you'll see several properties and drop-down menus appear. These are more or less all the properties of this node, and this menu will change depending on the node type. Some of them may be obvious, like in this case, disabled. Means it can be used. Some may be less obvious, like what does enabled focus mean? By the way, it has to do with whether a button can be highlighted or not. If you ever want to know what any of these do or how to access them in code, all you have to do is highlight over it, and a highlight menu will appear, giving you the property, which is how it will be accessed in code, and a brief description. Right now, I want to edit the text of the button. So the button has something our player can read when the game plays. We can edit that property up here in the text box next to the text property in the inspector. I'm going to write add paper because this is going to be a paper maker clicker game. If we test our game again, we'll notice a pop-up box that says our main scene has never been defined. The main scene is the scene that first starts when the game runs. For some, this will either be the main menu or maybe a loading screen. But for now, we're just going to use this game scene as our main scene. Okay? We can always change it later if we want. So we'll click select, okay, and then click open. Now we can see that when our game runs, our button says add paper. But what if we want to actually do something? Okay, it doesn't do anything right now, it just clicks. It's time to do some coding. Stop your game, hitting the stop button at the top. Now, in order to write code, we need to add scripts, which are just files that store the code you wrote. Scripts can be attached to any node. For example, if you have multiple enemy nodes and each one behaves a different way, you can attach different scripts to each. But for this game, we're just going to attach our script to the main node. So it can control all the other child nodes, like our add button that we put here. To do this, we're going to click on our world node. And then in the upper right-hand corner of the scene tab, click on the attach new or existing script button. Okay. You can also right-click on the world and click Attach Script. Okay, and you can do that to any node. So an Attach Node Script window pops up now. If we wanted to attach a script we already wrote, we could use the file browser down here. Otherwise, Godot automatically names our script with the same name as the node which we created it. We could name it if we wanted to, but for now, I'm just going to keep it the same. So I'm just going to click Create. And that automatically brings us into the script editor. You can toggle between the 2D viewport and the script editor by clicking them up here. To the upper left, we have a list of all our open scripts. It's just one script long because we only have one script right now. In the lower half, we have a list of all of our functions, which we'll go over in a little bit. To the right, we have where we actually edit our scripts. All right, so this is the default document with several nodes. I like to think of this as separated into 4 areas, okay? Up here, we have the variable, declaration, area. Okay. And I'm going to delete the existing notes on here. So it looks like this. Note that we just added our very first piece of code, writing notes. Anything that comes after the pound or number symbol will automatically be converted into a note. When the game runs, it will ignore any of this text, and Godot tells us that the text will be ignored by turning it gray. You can add as many pounds as you like. I just like to add multiple pounds, depending on the importance of the comment I'm leaving myself. So the other areas of those four are the ready start function. Okay, the next one after that is the process run function. And then finally after that is our area for custom functions. And we'll talk about what all of these do as the video goes on. Let's start by talking variables. You can add a persistent variable, one that doesn't change from frame to frame unless we make it, by writing the letters VAR up here in the variable declaration area. Then, after that, we're going to write the name of the variable. In this case, I'm going to call my variable paper. It can be anything that you want it to be. If we'd like to assign a value to that variable, we can write equal and then write the value. In this case, I'm going to write 0 because we want the player to start with 0 paper. Variables don't just have to be integers. The most common variables we'll probably use will be integers, which is a number. And there's an example of an integer. We can also do booleans. And there's an example of a boolean, which is a true or false switch. We also have vectors. A vector holds 2 or 3 related integers in one variable. We have strings. Strings hold text. Finally, we have arrays and dictionaries. Both of those are forms of lists. It isn't super important that you memorize all of the names of these variables, just that you know that they exist. As we practice, you'll start to understand more about what they are and how to use them. Okay, so I'm going to put a number sign in front of all of these examples. That way you can keep them if you'd like to reference them later. Now that we have something that tracks the number of paper, our paper variable that we created up here, we need a way of both increasing it and seeing that it has increased. For this, we're going to head down to the process function. Now the process function runs once every single frame. Since we want our code to check if the button is being pressed once every frame, this is where we're going to put our code. So right now, we're going to introduce something called a logic statement. A logic statement is a 4-part statement that goes like this. And I'm going to put it as a note so it doesn't affect our code. 1, our logic statement says if. So it knows that it's checking if something's happening. Number 2, it checks to see what's happening. So if something is happening, okay. Part 3, then. And part 4, do something. So if something is happening, then do something. And that's pretty much the basis of all code. Sure, there's all sorts of fancy stuff you can do, but none of it will work without this one basic if-then principle. What we want to do is say, if the button is clicked, then make paper increase by 1 and show us how much paper we have. Okay, pretty simple, right? So to do this, we're going to start with the word if. And then we're going to add a space. A space tells the program that we're moving on to that second part of our 4-part statement. Remember, every time you add a space, it moves on to the next part of your statement. Now we need to detect what's going on in the button. So we need to access the button node that we created. There are 2 primary ways of doing this. I'm going to show you the convenient but potentially slow way first. We'll start with a $sign. This tells the program that we want to grab one of the child nodes of the node the code is running in. So the add button node is the child of the world. It even pops up a handy autocomplete menu down here for you. So we're just going to write add button, or better yet, I'm going to use it. Remember how we did an underscore when we named it? This is why. If there had been a space in its name, we wouldn't be able to access it because the space would tell us to move on to the next part. Now that we have access to the button, to access its properties, we have to write a simple period. If we wanted to, we could check a whole bunch of other things that might happen. But right now, we're just going to check if it's been pressed. So add button.pressed. And that's it. If the button is pressed, this is going to return true. And therefore, it's going to run whatever happens in that function. Okay? If we wanted to, we could continue checking for other things by writing and or. But for now, we're just going to leave it as is. So in order to tell Godot that we're ready to move on to the second half, or to write part 3 of this 4-part statement, instead of writing the word then, we write a colon. Okay? Colon means then. And then we'll press enter to move to the next line. So right now we have a statement that says if the add button is pressed, then do something. We don't have anything right now. That's the 4th part. So this is where we tell Godot what to do. Notice how the next line is tabbed over, represented by this little arrow line symbol right here. That means everything here is going to be a child of the line above it, which controls whether or not it happens. So what do we want to happen? Well, we want the paper to increase, and we want to display the amount of paper. To increase the amount of paper, we access the paper variable we created by writing paper. Okay? And then we say that it equals itself plus 1. Now in math, you know that this is an impossible statement, right? You can't equal yourself plus 1. But in code, all this says is to change paper to 1 more than it was in the previous frame. It's perfectly acceptable to write it this way if you like, but we can also simplify it just a little bit more by changing this to say paper plus equals 1. Both of these statements mean the same thing. What's cool about these equations is you don't have to do just plus equals. You can do other math equations as well if you want minus equals, times equals, divided by equals. For now, we're keeping it simple and doing plus equals. Now I'm going to press enter to move on to the next line. And since we're in the same tab level under that first logic statement, we know that this part is also going to run. And since it's under paper plus equals 1, we know it's going to run after it. Now we're going to use a function called print. Print is going to print anything into the console down here. Anything that we want to be printed has to be in parentheses. So I'm just going to put paper. What this will do is print the newly changed amount of paper, since it comes after paper plus 1, down here in the console area. It's a text box that we as developers can see. And with that, let's run our program. Up here we can see our button, and down here is the console. Now, check out what happens when you press the button. The console prints an ever-increasing number. Great job! You made an interactive button. There are a couple problems with this. For one, the player will not get to see the console, so anyone who plays this game won't know the button is interactive. And second, this is supposed to be a clicker game, meaning the button should increase the number by 1 only once per click, instead of just increasing it by 1 for every frame that you just hold the button down. Is there a way to fix this? Of course. But that's going to happen in the next episode, where we'll fix both of those problems by learning even more about Godot. Thanks for watching, everyone, and great work today.